Hey class, I just want to give you another short little video discussing voltage dividers. Voltage dividers, if you remember what a voltage divider can look like and a simple way to calculate them, it can save you a lot of time, honestly, through the rest of the semester. So it's a good trick to learn and remember. So first, to understand, a voltage divider means, let's say we have a voltage source and we have two resistors, R1 and R2. And let's say for some reason we want to measure the voltage across a resistor. Well, this voltage source, Vs, once the current's going to leave Vs and eventually get back down to ground. So all of that voltage is going to have to be consumed through those two resistors once it gets back to ground. So the amount of voltage that's consumed is proportional to the resistance. For example, if R1 is very large compared to R2, it'll probably consume most of the voltage compared to R2. And so a simple calculation of this, it can be derived by doing Kirchhoff's loop law, just starting right here and going clockwise by assuming a current I. We can start and say, alright, we're going to increase in voltage Vs, so plus Vs. We're going to go across the resistance R1, which is a voltage drop, so minus R1 times I, and down to another voltage drop, so minus R2I, and that gets us back to our starting point, so that equals 0. If we rearrange and solve for I is equal to Vs over R1 plus R2. Now, if you really want to know what is the voltage across R2, or this output voltage, it's the same thing as the voltage that's consumed through the resistor. So the output voltage is equal to the current going through that resistance times the resistance. So this is Ohm's law. And we already solved for I, so if we plug that in, rearrange a little bit, we get R2 over R1 plus R2 times the source voltage. So, if you look at this equation, the output, we're measuring across R2, and its output is proportional to the input by the ratio of the resistance you're measuring across over the total resistance. Okay? And if we wanted to know the voltage across the first resistor, well, if we remember that rule, it's equal to some proportion of the source, and what it's equal to is the voltage, or the resistance you're measuring across over the total resistance in the loop. Okay, this is handy, for example, if you have more resistors. Let's call this R1, R2, R3, and R4. And let's say we want to know this voltage V out. Well, we can combine these top two voltages to be an equivalent, or top two resistances to be an equivalent resistance, and the bottom two resistances to be an equivalent resistance. And now we really only have two resistors, so it looks a lot like a voltage divider. So we could redraw it as this, with this being our output voltage, where this top resistor is really the sum because they're in parallel, R1 plus R2, or I'm sorry, because they're in series, we just add them directly, they're R1 plus R2. The bottom two, because they're in parallel, we can find the equivalent resistance by adding them in parallel, which will end up giving us R3 times R4 over R3 plus R4. So now V out, if we call this RB and this RA, V out is going to be RB over RA plus RB times the source, which we can then substitute in for RB and RA to get R3, R4 over R3 plus R4 over RA, which is the sum of R1 plus R2 plus RB again, R3, R4 over R3 plus R4 times the source. Now that's pretty messy, but with some simplification, we can clean it up just a little bit by multiplying the top and bottom by R3 plus R4 to get R3, R4 over R1 plus R2 times R3 plus R4 plus R3 times R4 Vs. So because of our voltage divider, we could quickly get to an answer, whereas if you didn't use your voltage divider, you would have a couple loops to do a mesh analysis to find the current through R4, and then you'd have to find V out by saying V out is equal to I R4, whatever that I turns out to be. So in the end, it's a time saver once you get comfortable with it, but the best way to get comfortable is just by practicing. This algebra step, yeah, it may look messy, but it comes a little easier with practice. So I hope that helps understand what a voltage divider is and how it can help you, because we will use it quite often throughout the class.